we're going to find the inverse of an equation. And here's the equation right here up on the left. It's a logarithm. And the procedure for finding the inverse is the same as it is for any equation. We're going to first rewrite f of x as y. See, I have that procedure on the right. And what I mean by that first step is you literally just say y equals. And now you have the rest of it. Just keep writing it as it is. So I like that y equals because it keeps all the algebra that's going to follow this a lot easier to keep track of. Next, we switch the x and y. Okay, so you literally just switch their positions in the equation. All the x's become y's, all the y's become x's. Everything else stays exactly the same. And now comes what is really the only hard part when you're finding an inverse. This step number 3 right here, solve for y. That means get y by itself. And what I like to think of when I do this is, how am I going to pull all these things off of the y? See, there's a lot of junk going on right here all around the y. How am I going to pull those things off? Well, let's go one at a time. First thing I'm going to do is I'm going to multiply both sides of this thing by -3. That's not subtracting 3. That's multiplying by -3. And you see what that's going to do? It's going to cross out that denominator right there. Okay, so let me clean this up a little bit now that you know what I'm doing. And let's write the next part of the equation down here. So that's going to be, let's see, back to my green. It's going to be -3x equals logarithm of y minus 4 minus 5. Now remember, we're still working from the outside in towards y, so the next thing I'm going to attack is that -5, and I'll just add that over to the left side. I say plus 5, and that cancels out the -5. Now I've gotten about as far as I can without using logarithm tricks. I've done the easy division, multiplication, addition stuff. And what I want to remind you at this point is this logarithm has a base right here that we don't write. It's typically invisible. It's like the square root. You don't write the 2 in the square root. 10 is so common we don't even bother writing it. It's called the common log. But I need to remember it's there because the next step, what I'm going to do, is I'm going to take this logarithm and try to turn it into an exponential function by taking that base, raising it to this power on the left, and saying equals the argument of the logarithm. Okay, this is the swoopy thing that we do in class a bunch of times. So when I rewrite that, look what it turns into. It turns into 10 to the -3x plus 5 equals that thing in the logarithm, y minus 4. These right here are equivalents. These mean exactly the same thing. It's like the same equation just written frontwards and backwards. But I like the way I've written it right here a lot more in blue because now y is almost by itself. I just need one more little thing, just plus 4 to each side, and then we will have this thing wrapped up. So I'm going to say -3x plus 5, and then let's add a 4 onto this. Okay, and that is our inverse function. Okay, this y right here, remember that's inverse of f of x. Okay, so we're going to take that and stick it up here, and that would be your answer. Now, one thing to keep in mind, when you're writing this in the computer, you may have a little trouble with this. If you have a complicated exponent, you're going to need parentheses on that, but that's a minor detail.